Okay, awesome. Next up is Mathieu Geukens. Mathieu has a academic background in economics, is my understanding, and now working as a software developer. So that's a perfect combination for crypto. He is working on tokens and smart contract scripting capabilities in the Bitcoin Cash ecosystem. And he's going to talk to us today about unlocking the power of Bitcoin script. Welcome, Mathieu.
Yeah, thank you for that introduction, Anthony. Hello, everyone. I'm super glad to be presenting here at the third annual Electronic Cash Conference here in Barcelona. Let's see if I can get the... Yeah, so my presentation will be on the topic of unlocking the power of Bitcoin scripts. First of all, I want to have a general message and say a thank you to everyone who pushes peer-to-peer electronic cash forwards in the original mission of Bitcoin to bring economic freedom to the world. Because even though there are thousands of coins in cryptocurrency, there's actually quite a remarkably few focused on this original mission. So this is a moment of appreciation for the remnants, everyone who's building and promoting peer-to-peer electronic cash, with a special shout out to Amari there in the back for creating eCash and Bitcoin Cash. So 1 moment. Some background about me. So my name is Mathieu Geukens. I'm a Bitcoin Cash developer. I joined the cryptocurrency space during the bull market of 2017. This was when a new wave of people became interested, including myself. And it took a bit for me to figure out the landscape and to realize kind of the whole block size debate and the kind of mission for Bitcoin. And so this is when I became involved in 2018 in Bitcoin Cash and had a strong conviction for this original scaling vision. So I studied economics, and once I graduated, I became a full-time developer. That was in 2022, so already a few years ago now. And these are the 3 main projects I am involved with. So the first logo is CashScript, which is a high-level language and toolkit for developing smart contracts for Bitcoin Cash. Secondly is a wallet, CashNice, that I created for transacting with cash tokens. And lastly is my novel decentralized application that I'm building called Parity USD. So it's a decentralized stablecoin. So all 3 kind of are background which informed me for this talk to talk about scripting capabilities. And the quote, this is a paraphrase quote because I didn't attribute it to anyone, but kind of the idea that got me interested in the scripting capabilities and the smart contracting in Bitcoin was hearing on some Bitcoin cash-related podcast that actually the script system is the most interesting part of Bitcoin. And I didn't know pretty much anything about the script system. I was interested in Bitcoin from an economics background and maybe the distributed nature, the consensus. So it was really remarkable that this archaic script system to a developer was the most interesting part. But in my talk, I will try to convince you that indeed it is a fascinating core aspect of Bitcoin. And in the rest of my talk, I'll use Bitcoin in the broad sense. So this is not referring to BTC, but to all Bitcoin-like chains and forks. All right, so when we think about the script capabilities, we want to think about Bitcoin as programmable money. So programmable money also means that you have an application layer. Cryptocurrency as an application platform for developers to build on. And these apps are they're encoded on the blockchain as smart contracts. And this application platform is actually the most permissionless application platform of them all. Because if you want to publish to an app store or to many other software platforms, you need registration, sign up, there'll be a whole process of setting who you are, what your code is doing, asking for approval. But when you publish a smart contract, nobody will ask you or can deny you any access or permissions. So I think this is a remarkable trait, and it's really inviting to young people or just entrepreneurial, people who can just build without having to prove anything about themselves. Smart contracts in script allow for disintermediation. That's like a core value add they have. So they inherit the same properties of Bitcoin itself, but of being non-custodial and trust minimized. So of course you could create an applications which reintroduce trust, but the core value add is that the application that you can build can be non-custodial and trust minimized. The most famous smart contract probably on Bitcoin are multi-sig. So these are like for a company, for example, you don't want one person to easily be able to run off with all the money. So multi-sig has historically been like the most used custom spending condition that was written in scripts. But I think generally the script system is uniquely suited for financial applications because financial apps benefit from this non-custodial and trust minimized nature. So think about derivatives, financial assets, which can be tokenized, yield instruments, crowdfunding. So I think anything related to finance has benefits a lot from these properties. And that's also why we see in the wider ecosystem that these are the kind of apps that people develop first. Here I have a kind of table of elements, but then for scripts. So this is laid out according to their hex number, but also colored according to the category in which the different opcodes fit. And this is a website, so you can visit it at vm.cash. I did not build this, but I think it's a great resource when we talk about scripts. At the top left-hand side, there's filters for which years different opcodes are added. And the grayed out opcodes are the ones that are not active or not present in these years. So you can see, for example, here there's a row missing. That's because there's a bunch of push data opcodes, which are not too interesting. But other ones, are very relevant, especially the ones which have been added in 2018. So shortly after Bitcoin Cash was created, a lot of work had been put in to re-enable, but also extend the scripting language with core primitives. So this includes some of the things they still talk about now on BTC, for example, opcats. That's very important also. What Finn mentioned in his presentation to enable governance is this check data sig and check data sig verify. So the two here at the bottom right. So why did they even need to re-enable these opcodes? Well, it's when Satoshi left, I think in 2011. He was fixing up a few things about the VM before he left. So he introduced many limits, and he also stripped out a bunch of opcodes, including opcats, which left the VM in a weird state because it used to have advanced capabilities, which could be used to create a lot of interesting apps, but then they were stripped out when Satoshi left. And so in this sense, the 2018 upgrade was a major unlock for scripts and allows many of the interesting things, for example, that Filarmani mentions, and that is the main difference of scripting between BTC and eCash. As it says there, BTC devs who are interested in scripts are still aspiring to have opcats and still want to have op-check data sig. But they give it a different name. They could call it check signature from stack because I guess they don't. They have to invent their own naming. So, as a general thought about the current state of scripts, I would say development for eCash has been mostly on other areas than scripts since 2018. So 2018 was a huge unlock, but then other areas have been prioritized. So now I want to kind of make a case for reprioritizing script development. If you ask anyone who has developed and worked with script what the problems are, I think you will get very similar answers. First of all, there is a need for roundabout emulation. For example, if you want to do math, 64-bit math, then you need to do this through emulation. You need to do truncation of numbers and make workarounds because natively in Bitcoin, only 32-bit integers are supported. Similarly, operations like multiplying have been stripped out when Satoshi left and are not enabled. So even for doing simple multiplication, you need to do a roundabout workarounds and emulate this functionality. And then lastly, introspection. So this is enabled by check data sig, but that is kind of and hack itself, because check data sig, the main thing it does is it checks the signature. So it's used for verifying, for example, an Oracle message. But if you want to use it for introspection, you have to do it in a roundabout way, kind of emulate this functionality. So emulating is kind of extra complexity for no inherent reason, but the emulation itself would not be the main problem. The second problem is actually that the VM limits we have are very badly designed. They were kind of put in place by Satoshi just before he left. He did some benchmarking. He said, oh, the script system is actually very vulnerable to exploits. Let me put in many limits. But he kind of sneaked these limits in, so they're not explicit. They're kind of implicit and depend on the encoding and serialization of many items. So it's very hard to tweak one number and to actually reason about what it does, because the numbers depend on each other and they're not explicit. So it's easy, for example, on this 201 opcode limit, you bump it to double the size, for example, 402, and suddenly you break a bunch of things or enable a bunch of exploits, and that's denial of service behavior. So these two limits, the 201 opcode limit and the 520 byte size limit, are like a general script problem that any developer who has worked with scripts will complain about. And then lastly, there is just, because few people have built apps with it, there is a lack of accessible high-level tooling. So these are like general problems, and especially the interaction between the need for emulation and these very low limits is problematic. Because, okay, we need to emulate 64-bit maths, multiplication, introspection, but we can only fit 201 opcodes. So before you know it, your script is too large and you need to cut functionality. I've been interested in Bitcoin script for quite a long time, and so I've been following the discussions in Bitcoin Cash about these about scripts. So there were public script meetings. I have a few here. So this was in December 2019 up until January 2020. So over 1 month period, there was like public discussion in Bitcoin Cash. Like, what do we want for the script system? What is our vision? And it talked both about incremental steps, so like small upgrades, as well as like the big vision. Where do we want to go 5 years out, 10 years out? And what stood out to me is for the incremental steps, there was kind of a plan. For example, op reverse spies had been added, but there was no big plan. There was no good idea of where did we want to take it 5 years after or 10 years after. And we can also see that probably why in eCash, now 5 years later in 2025, there has not been work prioritized on scripts. But actually there was kind of a vision about what we could do with scripts. And this is by Tobias Reck 6 years ago, so that's even before these script meetings. And the idea was, is it possible to bring MakerDAO on Bitcoin Cash? Can we build MakerDAO on Bitcoin Cash, introducing what's now called Mitra, a new transaction version? So Tobias had been thinking about like what the big vision is, and he was one of the ones to very publicly articulate it and put it out there. And I'll use some of his slides from back then to talk about the main problems with script to build cool decentralized applications. In this case, a decentralized stablecoin. So what did we understand 6 years ago that were the main problems? Well, as it says here, the 3 main problems hindering contracts are redundant repetitions, outdated scripts, and unverifiable tokens. I'll expand on this more, but first we'll dive into this outdated script item with Tobias' slides. He says the outdated scripts has 4 sub-problems, mainly outdated stack operations, limited arithmetic, wasteful loops, and no transaction introspection. So you might notice that some of these items we have already mentioned as general problems that come up again and again with this need for emulation. And I would say Tobias was right. So 6 years ago, we understood and we accurately identified the problems. So a big shout out to Tobias for that. However, there's multiple ways to go about the solution. And as someone who has actually been putting in the work over the last few years to actually build a decentralized stablecoin, I can speak from experience what my main problems were with scripts, or which problems I needed to be solved first before it was possible for me to start building this kind of decentralized application. And first of all, you need native fungible tokens. And native in this sense means script verified. So that you can write a contract, and if the contract can restrict how many fungible tokens leave to some user and how many are retained in the contract. And this is pretty well understood. Then secondly, I would say more importantly, are native NFTs. And this aspect is well less understood generally. So why do you want NFTs? People maybe think about like art, JPEGs or something. But in the context of UTXOs, an NFT would be used to keep contract state. So this would be like an NFT that can mutate its own data. You can also use an NFT for authentication. Contracts can authenticate each other, or a contract can authenticate a user, which has, for example, a receipt. And a specific example would be you have a staking pool, the contract gives out receipts, and wants to, of course, authenticate when it gets the receipt back. And lastly, it can attest to some state, so it can create like proofs or like contract verifiable messages, so contracts can communicate to each other. And these are just broad categories enabled by NFTs. So I would say that was a second main thing that I needed to even think about building Parity USD. And then lastly was actually to solve this need to solve these roundabout emulations. So probably the emulations would be possible if you have the high script limits, but it's of course better if you don't need to think about a roundabout emulation. So as it says there, not even loops or VM limits are required. Even though that Tobias initially, when you think about MakerDAO, in the MakerDAO design, you probably do want loops and you probably do want higher VM limits. So that's not a strict requirement. So the main thing, again, if you look at, from my experience, what's needed is really these tokens, native fungible tokens and native NFTs. So these are hard requirements to have script verifiable tokens. So let's talk about these script verifiable tokens. What does it mean? And kind of where can we place them in our mental map? So first of all, tokens of course are a very important building block for many applications. I would specifically say that they're super important to integrate with each other. So if you want an integrated DeFi ecosystem, you want some swap service, or you want other services to build on top of your tokens and enable other financial primitives like lending against your tokens. And so this is all only enabled by having script verified tokens. The problem is once people started trying to build this, especially the people on BSV have put in a lot of work to try to build script verified tokens, and they called it the back to Genesis problem. So if you try to build script verifiable tokens without any network upgrades, you cannot do it because the proofs kind of grow and grow, and you cannot prove it all the way back to Genesis. Except when you have opcat and SegWit. So in this sense, if Bitcoin BTC gets opcat, they can have script verifiable tokens and solve this back to Genesis problem. And I think here's a visualization. So in the current transaction format, V1 or V2, you have this problem where you have the proof bytecode, and then you include the parent, but the parent again has a proof bytecode, and then you see the grand parent, and the problem is this yellow part is always repeated. So there keeps on being proofs and proofs and proofs, so you cannot prove kind of back to Genesis because this proof always grows with each step. Whereas if you can kind of create a detached proof, then you only have one yellow item, meaning one proof bytecode, so you solve this back to Genesis problem. So it's a bit of a technical problem, and SegWit was not created specifically to solve this. It's kind of an accident that SegWit does solve it. But by the reality of BTC having SegWit, if they now add opcat, you can build these script verifiable tokens. So the reason why we have not seen script verifiable tokens on Bitcoin Cash, on BSV, and on eCash is because we don't have SegWit. Like if you would have adopted, if you would also have had SegWit, then just by re-enabling opcat, you would kind of get them by default or by accident or just right away. So how I would say it is detached proofs are this core unlock for script verifiable tokens, and we almost had them, by accident. This comes from a blog post about a thing called PMV3, so this was also considering a new transaction format for Bitcoin Cash, and we did not go forward with this, but I think it's still great research to understand why it's not possible currently and why it would be possible with, for example, SegWit or anything else that detaches the proofs. So it's not it's not included in this way recursively with proofs that grow over time. When we think about Bitcoin script, we can think about, do we want to restore it or replace it? And there's arguments to be made for both. Let's start in the middle, actually, with ideas to replace the whole VM. Recently, there has been more talk, even with Ethereum, to replace their virtual machine, even though it's been very successful, the EVM, to replace it with RISC-V. Similarly, there have been ideas to add a second virtual machine that runs WebAssembly code. And you can argue that WebAssembly might or might not be capable for something so consensus critical, but at least people have been thinking about just adding a whole new VM and kind of ignoring these experiments that Satoshi started. Or lastly, you could have just say we don't want programmability on the layer 1, so we don't even need any new VMs. We just do programmability on sidechains, or we don't do any programmability at all. Of course, if you rely on EVM sidechains for programmability, then this brings all the drawbacks of EVM. So bad scaling, the account model. So in some sense, this is not, you cannot, of course, beat the successful EVM chains just by also adopting EVM as a sidechain. So I think we, of course, want to do much better than what exists. So the remaining idea is to fully embrace script. The script system is based on, is a Forth-like language. So, and Forth is considered rather archaic, but it was actually a very good choice, I think, by Satoshi to base the VM language on Forth, because it's simple enough to implement and it's very concise. And it's, in this way, easy if you have multiple node implementations for them to be in exact consensus. But what does it mean to fully embrace scripts? Well, if we want to embrace scripts, we need native introspection. We would want to fix the VM limits. And we want to add some of these missing Forth primitives, which are loops and function calls. So of course, any programming language that you can think of will have loops and an ability to define and invoke functions. This is currently missing in Bitcoin scripts because of historic reasons. But I think if we embrace script, we should really consider adding these Forth primitives. And then, of course, lastly, but also importantly, is to develop high-level tooling. People do not want to write opcodes by hand and know this whole periodic table that I showed earlier by heart. So it's much nicer to have a high-level language with a compiler that compiles down to Bitcoin scripts. But this tooling needs to be developed, right? It does not fall out of the air. So if you want to embrace Bitcoin script, you should prioritize building nice high-level language tooling. This slide is called "Which Way to Go, Modern Man?" Because it's the idea also about whether to restore or to replace is currently also a discussion that's playing out in the BTC community. Blockstream, the infamous company, has two proposals that they're kind of putting out there. One is simplicity, which you might know, is their idea for I would say a rather academic language to replace the whole virtual machine. And they would not literally strip out the existing one, but they would add a new virtual machine and kind of deprecate Satoshi's design. Or, instead of replacing it, they also have kind of ideas for the great script restoration. And this would, of course, restore the script to its full functionality, so avoid this need for emulations, add loops to the script. So I think it's very interesting that many researchers are now thinking along the same line. So even in BTC, they are considering whether to embrace and restore Satoshi's script. I would say kind of accepting many of these ideas that Tobias put out 6 years ago. So eCash, in my mind, also has a choice to make over the coming years. Whether to embrace script, add a new kind of virtual machine, whether to offload programmability to a layer 2, or whether to not bother with programmability at all. So that would be kind of the choice by doing nothing. But I think it's very good to be mindful that these discussions in 2020 that I showed, these script meetings, they were never fully resolved. There was never a big vision about where do we want to take the programmability. Bitcoin is programmable money, but what is the eCash vision for this? Yeah, so I would really encourage to make a coherent long-term vision for scripts and to pick kind of a roadmap on this. Right, so I'm a Bitcoin Cash developer and I quite like what we have to work with. So I'll talk now about the benefits of the BCH approach. And I think these are arguments to consider when thinking about eCash's future for the scripting system. First of all, one benefit of the design that has been chosen for Bitcoin Cash is that Cash tokens, the native tokens on BCH, did not break the transaction format. So they were compatible with the existing indexes and infrastructure. Also, we did not have to wait for a native introspection for on a new transaction format. We just kind of embraced the existing transaction format and added native introspection fields for what was already there. And I think this was also a big unlock because it allows for current much easier decentralized application development. Next, recently in Bitcoin Cash in May, there were these implicit limits of the virtual machine got reworked to be explicit limits. And what this enables, these retargeted VM limits, they enable to add new primitives like loops and functions. Because suddenly, instead of implicit limits, which are hard to reason about, and you change one thing and everything breaks at another place, when you rework the limits, which is a bunch of work and needs careful testing, but then you can very well reason about the virtual machine and things like resource exhaustion from scripts, which enables new primitives, or which enables you to, in a safe way, add new primitives like loops and function calls. And then this last item here is when you add these new primitives, you unlock a bunch of new tooling work, but it's in a very good sense, because then people can start working on compilers and start working on analysis tools. And for example, they want to know suddenly how close am I to this maximum VM usage. Whereas before, now you have the tooling them on opcode limits, so you could just count opcodes, but once you rework the limits, people want to know how close am I to getting these limits. And a practical example would be you have a loop, you do something for all inputs. Well, it probably works if you only have a few inputs, but what if you make a transaction with hundreds of inputs? Does the computation not get too expensive in that case? So these are some of the benefits, I think, of the BCH approach. And first of all, is not breaking the transaction format to add native tokens. Here I have the periodic table again, but then with the year 2026, so the upcoming year, and this is for Bitcoin Cash. So some of the opcodes we will be adding are these new primitives, specifically begin and until, that you see there on the left-hand side. This is for a loop, so you have begin and until, and this is the loop construct. And then secondly, for control statements, you have define and invoke. And define is a way that you define a function, so a series of opcodes, and then you get a number, so you define them, for example, at index 1, and then invoke, you just call this function. So for example, if you have a simple thing that you want to calculate average, then you would loop over all the elements and do some division, or you can define a function that calculates average, and then if you, in multiple places in your smart contract, need to calculate average for some reason, then you can just invoke it instead of repeating these opcodes throughout. So in some sense, it's a size optimization, but functions are such an important concept in programming language that it's really also a qualitative difference. And then lastly, it also adds some extra opcodes related to bitwise operations. So the primitives are the most important, the loop constructs and these function constructs. So what is kind of the vision that I would suggest to the eCash developers here? If I want to make like a pitch about what should be done, then I think it would be very smart to think about standardizing on a CashVM. We need a counterweight to EVM as a standard. EVM has become the de facto, as it does have so much mindshare, so many developers, so much tooling and integration. And I think if everyone tries to compete with their own standard, then odds of success are much lower. It would be great, even though there's many forks of Bitcoin that we can share network effects, share tooling, and that, for example, for myself, if I develop an application for a Bitcoin Cash script, it would be easy to deploy on eCash. And even if I would not do it myself, then any one of you could just fork the code and deploy the smart contract on eCash. I think that would be a huge benefit. Of course, the main drawback of standardizing is if you are not the first mover, then you kind of accept the design that was chosen by others to some extent. So you have to be very critical that you like the existing standard before kind of just adopting it. But I intend, even with the application that I built myself, to show that this is a big unlock, for example, with having loops and functions and these native tokens, so that it is a standard that you might want to adopt. Also, network effects are crucial for the application layer to become an ecosystem. So, for example, you see this with EVM sidechains. If a chain has an EVM sidechain, the first thing they can do is they port Uniswap, they port Aave, they port all these important protocols that form an ecosystem, an integrated ecosystem where you can swap, borrow, lend, and do all these, have all these primitives for financial applications. And so I think that's crucially important, not only the network effect for tooling, but the network effect on the application layer. So my general hope with this presentation is to say that there doesn't need to be needless incompatibilities. You can tweak all opcodes and give them different names or change the behavior. But in the end, I think restoring script is pretty straightforward. Like we see with the BTC devs now thinking about the great script restoration, and Tobias Ruk's idea of 6 years ago, many ideas just come back in mostly the same fashion. So it would be great if we can have compatible tooling. So let's consider converging on the CashVM. Thank you for your attention. Yes, I'm ready for some questions. Yeah, for me, you can go ahead if I get the heads up.
What do you think is the most important feature you would like to add using these new opcodes when they come out? So if you're working on your stablecoin project now, were those selected in particular because there's a specific feature you want to add for some products, or are those selected because they're like important general primitives that you want to start extending from later?
Yeah, so the things like loops and functions are not actually things that I will need for my application, just because of the specific design. It already works on I could deploy it on mainnet. We're currently, and this is a premiere, we're currently undergoing like an audit, so the smart contracts are pretty much finalized. So we won't have to wait for new primitives. And the really big unlock was cash tokens. So to have native tokens, both for fungible, but then for these NFT use cases as well, where you can do authentication, keeping state in smart contracts. So that was like the biggest unlock. And for my application specifically, these loops and functions, they're like more general primitives. But for me specifically, they will. I think one application that will use them in a big way is things like quantum proof applications or zero knowledge applications, because then you want to do kind of cryptography on the stack. So you will want to do loops and call functions. So I think for those two applications, zero knowledge and quantum proof, you do want these new primitives. Did that answer the...
Yeah, thank you.
Yeah, that's a great question. And so I think the main thing Satoshi, I think, would have done different is these VM limits. So he ripped out a bunch of things that were already there. So clearly he liked this design. But by ripping out a bunch of things just before leaving and adding all these implicit limits, he kind of hampered his own system. Also, in some sense, he did not fully consider these denial of service vectors for a decentralized application, because at the top of the Bitcoin script file, for a long time there was Bitcoin does not have loops. And Bitcoin can perfectly have loops, but I think Satoshi went about it in a rather academic way, where he said, okay, if you do not have explicit loops, then at least you're limited by the size of the transaction. So even though you could, in the beginning, pretty easily crash, you could drain nodes from their memory, and because by just doing a bunch of signature checks in exponential way. So clearly he did not initially consider this until running the benchmarks, and that's why he put out the 201 opcode limits and the 520 bytes limits is when he actually did all the benchmarking. So I think if he had the time to reconsider, then he would not have all these very low limits, but instead think about how to have these VM limits in a coherent way. So I don't think he would suddenly switch to RISC-V or WebAssembly. Of course, I cannot know for sure. But some interesting experiments on this front is that, for example, in the Nexa blockchain, which is by Bitcoin Unlimited, there's some researchers who do consider RISC-V, and in the Cardano space, which is another UTXO model, they actually have multiple VMs. So they didn't want to commit to any specific one, and they changed their minds multiple times. So I think by now they have 3 different virtual machines, which are all different. So in some sense, the grass is always greener on the other side until you adopt the second VM, and then you think, oh, the third one will actually solve it. So in that sense, I'm pretty skeptical of these ideas that just a new VM will have properties, because in computer science, many systems are kind of theoretically equivalent, because computation is quite a general thing. So if one thing is has all the primitives like loops and functions and is Turing complete with some VM limits, then I think adding a new virtual machine does not have a big unlock. And that would also be my argument for extending the one we have instead of starting from scratch, because starting from scratch is much, much, much more work than I think adding a few needed opcodes or constructions to the one that Satoshi already in his brilliance already put in there. Did that answer the...
Okay, we've got a couple questions from the chat here. A question from Nate. He says, this presentation made a point that eCash pivoted away from the scripts in 2018. Does anyone in the room know why? It might help Mathieu's case for why it can be reprioritized in 2026.
So maybe it's a question better for the audience or for yourself.
Okay.
Yeah, thank you, Amari.
So there was not really like a move away, but it's clearly not the priority either. Though in the next upgrade we have some improvement on that front. But one of the recurring pattern that happened every time we wanted to make any kind of modification to the script system is that you have a lot of developers that come at it with the attitude that, oh, we need to do something, and this is something, therefore we must do it. And you end up with like a bunch of trash in the VM that you can never get rid of. And I think like your example was what happened with Bitcoin Unlimited, where they ended up implementing like 3 different VMs and whatnot, is exactly what happened when you go at it with that attitude. And there is a perverse effect in that. It's like when you have a lot of people that come with it with that attitude, like everybody else has to become much more conservative, or everybody, everything turns really bad really quick. And that's kind of what happened, right? Like this attitude actually slows things down quite a bit in terms of development. If you don't want to accrue, if you don't want to end up with 3 VMs.
Yeah, thank you.
Awesome. Thanks, Amari. And then one last question from Kane. Oh, maybe it's for Amari also. He says, Amari has mentioned the problems he sees with cash tokens since it's baked into the consensus layer. Would that be an issue for this idea of our standard CashVM?
No, not necessarily. Like if we put all the brain cycle into the CashVM and we define it properly and we go with it, it's fine. The problem with tokens at the protocol level is that you cannot actually, you don't get the security guarantee that you think that you get, right? Like the native token on the chain has special properties by the fact that it's evaded by the chain itself in terms of trust. verifying the other token with the consensus layer of the chain. Like, it may be a convenience for application developer, but you don't get the trust that you think that you do by using the consensus layer there, because you still have to trust whoever emits the token and does the rules. So, yeah, it's a bit of a like a lot of people are fooling themselves as to what they get when they do that. And obviously, what you pay for that is like it's very difficult to change anything once it's the protocol layer. So if tomorrow you're like, well, I have a new ID, a new kind of token or whatever that is not currently supported by the protocol, like what do you do, right? You have to do hard fork now, and it's it's a problem. And you do that to get stuff that you're not really getting at the end. Like you get that mostly to fool yourself.
All right. Thanks, Marie. And thank you, Mathieu, for the talk. Let's go on to Mathieu. Thank you.